Hello, hello. Hi, Brett. How are you?
How's it going? Going well.
Perfect, perfect. So, welcome everybody. We are starting a live that we do every 2 weeks. Today we have Brett. You have already seen Brett when Denise was in on holidays, and Denise decided to go to another challenge in another company. So we will not continue those open hours with us, but we will continue it, and we will try to get it working. These open hours was really the idea of Dennis. For me, it was really out of my comfort zone doing a live. So now I hope we are comfortable to continue that.
Oh,
So
for sure. We'll also get Dennis back as a guest. He's not done with us yet.
yeah, sure, sure. Still doing some things around Postgres also.
For sure.
Okay, so a few highlights. Let me just share my screen. Just to show something, I cannot talk too much about it. There is a banner on top of our website, but it says look at it tomorrow. So yeah, we will launch something new or going beyond what we have today. So let's stay tuned for that. Um, Without telling what it is, do you have something to say about it, Brett, from an application point of view?
I would just say that it's a huge milestone for the company and the product and, the future of distributed SQL. So this is just definitely a really exciting time, and I would just encourage people to be glued to social tomorrow and be ready to hear
Yeah,
what we've been working on, really.
and yeah, and there are some clues. We had a repo on GitHub where we put, and people from the community can test Postgres application, how they migrate to Yugabyte. And yeah, that's the same idea, being able to distribute Postgres without changing the application, but going much further there. One more thing, we had a new preview release. So just um, a quick explanation on the release numbers. Release numbers are always strange in all software. So we have the long-term support versions, we have the short-term supported versions, and we have preview versions that are not really supported. But you are encouraged to test the new features there, and we will be happy to have feedback on them. And just mentioning a few features there, for me the most interesting, something that I really wanted to see for a long time: instant database cloning. Because we had point in time recovery, but point in time recovery was like recovering to a new cluster as of, for example, as of yesterday, because you want to see how that data was yesterday. Now it will be as easy as doing a create database from an existing database, can be production, and getting instantly a clone on the same cluster. So it shares most of the files and can be really useful to debug issues, for example. And there are also, yeah, again, about Postgres compatibility, pgcron is now working in this preview version. Cross cluster with more automation and some performance things like that. Um, I don't know if you have something to add. If you look at those ones, I can say that there are so many new features that I didn't test all that yet. Huh?
No, I know PG Cron has been something that people have been very excited about, but that's about all I can say at the moment. There have been numerous presentations on that one.
Yeah, it's something I'm. Do you think it's a good idea to schedule job in a database as a developer?
I think we're seeing it more and more with a lot of Postgres extensions. A lot of stuff is being moved into the database for better or worse. I guess it's going to be a little bit polarizing. You ask 10 people, you probably get 10 different takes on it,
Yeah.
right?
Because as a DBA, I know that we need it because we will need to schedule some things like analyze. From a developer point of view, also depend if you're in a cloud, you may have services for that. If you are on premises, maybe you don't want to rely on other services. So yeah, can be useful. But anyway, it's in Postgres, and then we need to have it for compatibility.
Mm-hmm.
If people can say hi in the chat. Let me check if we have comments there. Yeah, we already have them. Hello, Pete is there. I think Pete will like the content. Yeah, happy with pgcron. Just use it with caution. Yeah, that's a good thing. It's not because there is a feature that you have to use it for everything. Yeah.
Mm-hmm.
And then let's go into the topics. So if people in the chat have questions about anything, just post it. We are streaming on Twitch. We are streaming on LinkedIn and on YouTube. And we follow the comments. And if there are no questions, we came with a topic that is active session history that was implemented recently and it's in preview. And it's not something new in databases in general. It's something I think that was invented by Oracle with this name, Active Session History. And it's not in Postgres, but it is in some managed services. And AWS, I think, was the first one putting that for Postgres in a managed service as Performance Insight. So do you want to tell us about it and show? I'm really interested. As a DBA, I've used that a lot in Oracle and in AWS, but I'm really interested also to see the developer point of view of how is it useful. The problem is that there are many tools that show a lot of metrics, but which one are useful for the developer? Just to know about the performance of the application queries.
Yeah, sure. I don't come from, a DBA perspective. I'm an application developer, just doing some basic performance benchmarking, trying to learn about different bottlenecks that I'll run into at the database layer. So what I've prepared is a bunch of PG bench statements, benchmarks that can be run against the database to simulate various bottlenecks that might come up, and trying to diagnose what queries exactly are the problem and what is being flagged within Amazon's performance insights. So I'm ready to show whatever I have. If you're ready for me now.
Yes.
All right.
Just share your screen and let's see what
All
we can
right.
see there.
So I have a Postgres instance running in Amazon RDS. So, Yugabyte is a distributed database. We just have a single node Postgres instance running here in Amazon, and I will just show, essentially what I would think to do as I'm running these benchmarks, and Franck can tell me if I'm looking in the wrong place or what issues might need to be diagnosed with a little bit more care. So here is my database. I've connected to it from my local machine, and yeah, we can see this list of tables that have been initialized as I've been using PG Bench to run benchmarks on my database. And I'm going to run a series of statements here. The first being trying to simulate lock contention on my instance. So essentially, I'm going to be updating the same row in my database repeatedly in order to simulate that lock contention.
And from 50 sessions, I see. Yeah.
Yeah, 50 sessions, five
threads.
threads for 60 seconds. And this is outputting every 5 seconds to my terminal here, showing what's happening. So we can go back into this. This is auto refreshing. So we can see here that we are getting a significant percentage of locks as we would expect because we are updating this PG bench accounts table repeatedly with a new value on a particular column.
Yeah.
So this is about what we would expect for a query of this nature. So I guess it's worth noting, you're getting an immense amount of data here in the performance insights. From an application developer standpoint, it's a little bit intimidating. I have all of these various metrics. I'm like, oh man, how am I going to figure out how all of this stuff
And you know that I think that a lot of DBAs do not even know what is behind because, in my opinion, it's not documented enough. For example, just I see CPU utilization. When I go to a system, I know that there is kernel CPU, system CPU, or user CPU. I think this one takes only user CPU, but I'm not even sure. I have to go to the documentation and test it to really know what it is. So my problem with this one is that it shows a lot of things, but you don't know exactly what is measured and difficult to interpret it.
No, it makes sense. And then I don't know, maybe this is a dumb thought, but what if you've changed various settings on your database, different buffer sizes, this, that, the other thing? How do you compare one point in time to another when you've done such things? I guess this is taking an average, so you could use the brush to zoom in on a particular period of time. That would probably be your best bet there, but just something.
Basically, those metrics are what was there before active session history in Oracle, in PostgreSQL managed services, and we will see Yugabyte later. And the big problem with them is that it's difficult to match that to what the application is doing. For example, if you see 0% CPU, is it good or is it bad? It's good because you are not overusing the database, but it's probably bad because you are not using the database where you are supposed to. And if you see 80% of CPU, is it good or is it bad? I mean, you are there to use the database, so it's good, but maybe it's just a query that is running away. It really depends on the results. And what you are showing now that is called their database loads, the good thing about it, what I really like about it is that it is easy to project what you see on the system, to project that to the user response time. Here, those bars are, if you put the mouse on it, we see a percentage here, but below in front of the query, we see 29.77. And this is a number of sessions, a number of active sessions. So you have run PG Bench from 50 sessions. Some sessions are just doing round trip to the network. They are not counted there, but those that are hitting the database at a specific time, at the time of sampling, are apparently waiting on a wait event that is a lock transaction ID.
Exactly.
So
which
basically, I can say that it is bad.
Which is exactly what we would expect as we're writing to the same column in the database.
Yeah. And I really like those little tests just to understand how it works. You expect a lock, then you expect that many sessions are waiting on it, and you can see it exactly. And then you know what you have to troubleshoot, this contention of a single lock.
Yeah, that was sort of what I was trying to get out of this experiment, was to run various things with an expectation in my mind of what should be locking or what I should be waiting on for these various benchmarks that I'm running. And then
so here you see the wait event that so how many sessions at a specific time. So those are samples of the activity. How many sessions are waiting on lock? You know the statement, so that's really good. And then you have to understand it and tune it, but at least you have those dimensions: the wait event and the statement.
Yes, exactly. So now I want to run another one that is going to have both select and update statements via this -n flag here. And now I'm going to use 200 clients and 20 threads for this one.
Okay.
We can see what is happening. So this, I'm not using a custom script of any sort. This is just a default from the PG Bench tool, I guess.
Yeah.
So we can head back over here and go back to our 5-minute time frame and see what is coming in. So we can see that we are setting a balance here.
So
Let's see, do we need to refresh this?
that's interesting.
Oh, this isn't what I was expecting to see.
Yeah. But the good thing also I like with that is that you always have something to discover. For example, I see client read, which I don't know exactly what is behind this wait event. It is documented, and I can also mention that the best documentation I've seen about Postgres wait events are on the AWS website.
Mhm.
That's interesting. You know the statement. The statement is end, which is the commit for the
Mhm.
transaction. So
Mhm.
at commit, it looks like it is waiting for something from the client, and I have no idea why.
This is very funny because I've run this bench numerous times, and essentially the desired demonstration for this command in particular was to show wall sync contention.
Because
So,
it's right. Can you show the screen just to be sure that there are no statement failed? So now it has stopped, but zero
nothing
failures.
failed.
500 transactions per second. Waiting. I have no idea.
Yeah, I don't know. Maybe when I'm done running through the others, I can investigate further and see if I can
Yeah.
simulate the correct issue there.
But the good thing is that there is always something to learn. Of course, needs more time to really understand. When I say I don't know what it is, of course, I can spend time to understand what it is.
Mhm.
But
So
yeah.
why don't we just go into explaining what the wall sync contention would be, or what you would do to like, if you ran into that issue, how would you go about fixing it on the database side? Like, is this something that you as a DBA have run into and managed in the past?
So the wall sync is the only point where the user must wait for some IO, because when you
Mhm.
commit, you expect that it goes to persistent storage, the durability in ACID, and then there is no other choice at commit to wait on something. And in a single instance server, it must go to the storage. In a
Mhm.
distributed database, we have the choice. It goes also to the network, and we can decide if we wait for the storage on all nodes or if it's sufficient to go to one. Before you continue, let me just show a comment. I didn't want to put some pressure, but we have in the chat Kyle Eiley, who has designed active session history in Oracle and has designed what you are showing, the performance insights. So I didn't show that, just not to put too much pressure there. Hello, Kyle.
Oh, very cool.
And then client
What a
read is
legend.
client read is like more data from client. Yeah. It's how long the client takes to consume the fetch data from the database. Just, yeah. So probably you are running from a client with high latency, and this latency is higher than writing to the wall.
Mhm.
It's a non-IO client wait for data, and it's not something to fix on database side. And Kyle has a blog post about it. So if we want to know more about client read, we have all information about that.
Very cool.
So probably, where is which region is your database and which region is your client?
Exactly. So my client is in US West and my database is in US East
Okay.
2, I believe. So that would make total sense.
Yeah, yeah, yeah.
So why don't I just run one more and we can get over to just showing active session history in Yugabyte. Does that sound good?
Yeah.
So this one is to simulate CPU bottleneck by executing a sum on the entire data set. So let's see.
And,
See if we
and
get.
a remark from Kyle that is also very, very interesting. Always, when you have wait events, you expect that it measures something that is not in CPU, waiting for IO, waiting for network. But the instrumentation of the wait event itself is done with CPU instructions, because you cannot do anything in a software without going to the CPU. And I think that that's what the command from Kyle is saying. If you have CPU saturation, then the measurement of the wait event itself is inflated by that. So it's
Mhm.
kind of, it runs to measure the end of the waiting on network, for example, but it is in the CPU run queue before being able to change the status there.
Totally makes sense. And here I'm seeing the wall sync did wind up coming through. This is
Yeah.
very, very interesting. I have not seen it so sporadic in previous runs of the bench. It was a little bit um, more consistent in how it was coming through, but we can see this is consistent with my prior tests that the wall right was weighted on. So we're not taking crazy pills, Frank. We did have that come through on the
Yeah.
past bench, and here we are showing the query to sum the balance column is hitting CPU as the top weight. So that should be expected. So what exactly would this flag to you? Is this in bounds as a DBA, or are you basically just learning here that, you know, doing a sum across your entire data set is a bad idea in general? Is
No,
it?
for me, this is really useful, because using CPU is okay, because I know that I can scale CPU. Just
Mhm.
it also scales the cost, but it's something that you can scale to the limit of the largest instance, for example. But what is really interesting is the number of active sessions there, 26. And it's really good to match that, the active sessions in the database, with the connection pool settings. For
Mhm.
example, here I know that my database can run 26 sessions in CPU, and increasing the connection pool will not help. So yeah, the
Mhm.
number is also very interesting from a database point of view. For example, if the application tells me your database is slow and I see nothing in the active session history, then probably the problem is elsewhere. If I see active sessions, then I know that I have something to tune there. In this
Mhm.
case, if you go to top SQL rather than top weights, we can see the statements, and then at least we know what we have to tune. at least I know that if I do something on this statement, I will impact the response time, because this is the most common one. Because without active session history, I see a lot of people tuning queries just because they see that it is slow in pgstat statement, for example, but without knowing if it really impacts the user. So here you can really take the top SQL statement and see what you can improve there.
And then you can change the number of concurrent clients and threads to sort of figure out what the relationship is with that and the CPU bound here. So is that something that you do frequently with your performance testing to try seeing if something is going to scale linearly or?
Oh yes, and that's what Kyle is also saying. I didn't see it on the small screen. You have this small dotted line that is the maximum vCPU. So here you have 26 sessions that need to run in CPU, but you have only 2 vCPUs. So this is overloading the server, and that's probably what you had before with the other wait event. The CPU is completely overloaded. So here we don't see that it is. The problem is that we know that the database has something to run in CPU, but from that we don't see that most of them are waiting in the run queue. Because the database doesn't really know that. But the good thing is that we can compare that to the CPUs.
Very cool. Well, thank you for the education. This is very cool and very new to me. So, and thank you, Kyle, as well, of course. So I'm going to.
What I really like with this is that before interpreting something in production, you can reproduce exactly how you did. You know exactly what your statement is doing. And then if you see something that doesn't match what you expect, then you can go to understand better how it works. Yeah.
Yeah, I have one of those that I was expecting to show IO contention, but it's actually just showing CPU. And I think the issue with that benchmark, or at least the issue in my logic, is that the data set wasn't large enough. So it was really just the CPU that was being hit instead of IO contention. So that's something that I'm going to look into further after this presentation.
Yeah, that's right. It's not always easy to reproduce problems because you have a lot of cache, not a lot of CPU, and yeah.
Yeah, and then I was going to look into increasing buffer sizes or turning off the synchronous commit on the database and see how that was going to impact the wall contention. These are just some things that I wanted to check out to see how it would impact the benchmark and the various metrics that we're going over here in the top weights.
Yeah. So this active session history approach has been implemented in AWS managed services, and Google has also implemented them. I think it's not called Performance Insights, but something Insight, Query Insight, I don't remember. And that's something also we have implemented in YugabyteDB. And I will share my screen and I will show something where it helped me to understand a bug that we had on real life style. So first I will run. So I have started a Yugabyte cluster there, and I have also started. I will show it with Grafana. For the moment, I don't think we show it in the performance graph. So I did my Grafana on the table, but let me first find what I wanted to run, which reproduce something that I've seen with a customer. So I'm just creating a simple table there, demo, with a primary key that is generated. Not hash sharding, so with a single shard. And I'm using PG bench here just to run a statement on it. So from 50 clients, like you did, showing the throughput every 5 seconds, like you did, and I'm running a transaction that inserts a random value there. And this is running at the rate of 800 transactions per second there. I will show you directly the graphical version I've put on it because it's much nicer. I really like Grafana. It's beautiful. It's helpful, but also beautiful. And let me refresh, look at the last 5 minutes and refresh what I see there. And let me explain it. So there is a bit more than what you displayed because we are in the distributed database. So we have multiple nodes. Here I have the smallest cluster that is protected with 3 nodes. And I'm showing the wait event for the 3 nodes. And also in those 3 nodes, we have 2 layers. We have the SQL layer and we have the storage layer. We connect to any node. In this node, we have the Postgres backend that passes a query, executes it. And of course, that uses CPU and network and something else. And the reads and writes are going to multiple servers. And let me refresh just to see. So I have something running there. So I have my 3 nodes there, and I'm connected to only one. I have 50 sessions connected to only one, which explains that at the SQL layer, I have some activity, around 10 active sessions there, on this node and not on the other nodes. Because on the SQL layer, nothing is connected there. In real application, you distribute the connections. But even if I'm connected only there, I can see activity on all nodes at the storage layer. And we will see the detail of those activity. We can already see from the colors that it's not exactly the same thing that is running everywhere. We have names for the wait events. And in the SQL layer, I see that I'm waiting a lot on storage flush network. This is the wait event where we instrument when the query layer sends some things to the storage and waits for it. So here I'm inserting row. Basically, the inserts are buffered and are flushed. And that's the main event, which is expected when you insert a lot of rows. There is something else that I didn't expect, and that it's also quite important if I show both. Catalog reads. And that already tells me that I have probably something to tune. One, I expect it. I insert, of course, it will go to the storage. But I do not expect to read the catalog, except during parsing or when reading the catalog tables. So I already know that there is something to tune there, and this is what we will see. On the storage layer, I can see mostly CPU because I don't have a lot of data. It goes mostly in memory, and some raft apply because it is writing. But first, we will see. We'll try to understand what are those catalog reads because they are not expected. So remember, I was at 800 transactions per second. I canceled that. And just to show quickly, my Grafana, probably I can show the queries that are behind. It's just querying a view. Well, this is a view I've created to read from all the nodes, but basically the information is in a view that is called YB active session history. So yeah, the name, just taking the name from Oracle. I don't know if it's a good idea or not, but people know that. The idea is that it samples the activity of the sessions and it keeps an history to look at that on time. So if I query that as is, I have samples every I don't even remember. I think we take them every 5 seconds by default. Let me see if we have a parameter config yb something hash sample size sampling interval. So every 1 second, and with a lot of information, and that's the goal of active session sampling, is that because it's a sample, you can get a lot of dimensions for each sample. So of course, this is quite hard to read. So we can do some aggregates on it, and I really like that we can access. So it was not on the right screen. I really like that we can access it from SQL, even if it's better in a graphical way. We can do a lot of SQL. So this is the big aggregation. Let me just show maybe not last minute, because I was talking for more than that. Let me show that 10 minutes. Yeah, I have many samples. And then again, for 10 minutes, I will group by the most interesting wait events there. So the wait event class, the wait event type. And here I have exactly the same thing that I've seen graphically. A lot of samples. For the wait event component, the query layer, YSQL, a lot of samples on network storage flash, but also many samples on those catalog reads, which I do not expect. And on the tablet server, so the storage layer, waiting for replica. So exactly the same information that I've seen graphically. You can do a lot with SQL. You can also show a lot with Grafana. Let me just show the comments we have from Pete. Hi, Pete. Does anyone else also see the need for a global view or something similar? Yeah, that's a good question. For my Grafana one, I created a global view that reads from all the nodes. But in Yugabyte, you can add or remove nodes. If you run in Kubernetes, you can add pods. So we don't have a view looking at all of them within the database and using the foreign data wrapper. But yeah, that's something I would like to have rather than creating it. And yeah, you need both SQL access and UI representing it, and that's really good. And with Grafana, I'm just querying the SQL ones. We have other commands. I will go through them, but first, let me refresh that. So that was the workload I had. And of course, when we have seen that at a user, we tried to understand those catalog reads because we do not have a good explanation for them. And there was a GitHub issue for that. And we had colleagues doing some traces to understand a bit better what was behind. So active session history was the way to identify that there is a problem and there is something to go further. Of course, you may need more details. And in this case, I will not read all through, but in this case, the reason was that the Postgres code that we use for this generated always colon is reading the catalog, which is not a problem in Postgres because the catalog is at the same place, but in a distributed database, the catalog is shared. And then the workaround is quite easy because in the issue, the colleague also mentioned that this doesn't happen for big serial, it happens only for generated always. And then let's create a table using big serial rather than generated always, which is exactly the same. It's using a sequence behind, but just the Postgres code is using it differently. And I run it, and let's look at the questions or comments while it is running. I will just show there what we see. Looks better. I have more session active, and then probably Yeah, higher throughput there. So let's see what questions we have. I think I skipped a question from Yao before about improving migration from the Postgres functionality. In our case, would like to run both Postgres and Yugabyte running side by side to mitigate risks. That's a really good question. And we have some customers who did that, running both Postgres and Yugabyte at the same time. They did that from an application, from the application, just to be sure, reducing the risk. So that's a possibility from the application. You can also use change data capture from one or the other. You can use logical application change data capture from Postgres to Yugabyte or from Yugabyte to Postgres. Our tool, the YB Voyager, also uses that to do online migrations. I don't know if it's a good idea to reduce the risk. I think it's better to do that from the application rather than relying on more complexity with change data capture. I don't know, Brett, if you did that from an application point of view, running an application that is doing double writes.
No, I've executed the live migration from Postgres to Yugabyte, and that's something that people can look into. We even have a 20-minute long YouTube video walking through that on our YouTube channel. But no, I haven't executed.
But that's
writes
also a
on
way
both
to
sides.
reduce the risk, because you continue to run on Postgres, you replicate to Yugabyte, and you have all the time to check that it works on Yugabyte before switching to it.
Yeah.
The problem there, I don't know if we do. Then when we switch, yeah, I think we do that, but maybe
So you take
better. When you
basically
switch, can you switch
we
back?
take a snapshot. We take a snapshot of the data, which can be applied to Yugabyte, and then any writes coming in on your Postgres instance will be added to a queue and applied to Yugabyte until the queue has been drained.
Yeah.
So once the queue has been drained, you can actually initiate cutover to Yugabyte and point there fully. But you could test, your instance with a subset of the data and initiate cutover once everything is looking good.
And when you do the cutover, can you switch back? I don't think that today we replicate on the other way, but that's something we will be able to do in the future, because we made change data capture to be Postgres compatible, and then you can apply it to Postgres.
I think so. We have live migration with fallback. Yeah.
And we had other comments or questions. Let me check. About performance site. If performance site showing 32 as the limit, as that is the max number of cores we have, but the wait event showing cross above that line with 90%. Transaction commit sync wait event, is that okay? So I think that transaction commit sync is on Aurora, or I don't remember. But basically, what I would say there, if you are using a lot more CPU than what you have, don't look at the wait events, because they are inflated by this. First, solve your CPU issue. And the second one, was continuation, or is that to be 100% of CPU and then cross beyond? Okay, if it's 90% of CPU, my problem with 19% of vCPUs is that you are using more than 100% of cores, because if you run on Intel with hyper trading, so 90% CPU usage is already a lot, especially if it's only user CPU and you can have some system CPU. Okay, and so then let's look at what I have there. So I have higher usage on the query layer, which is good because I have also higher throughput. Of course, if I use more CPU without having better throughput, something is bad. But here it's higher, and I have no catalog reads there. So I'm really happy. The problem is not solved. It's a workaround. It's fixed. I think it was pushed for the next version, the fix for it. But yeah, so the tip is that in current versions, better use big serial than generated always because of this, really, if you have high throughput. And I will not show the raw data. I will go directly to, I will show everything from the graphical ones. Let me see what we have. So can we go further? So here on the query layer, I'm quite happy because I was running 50 clients, and I have, of course, not 50 active in the query layer. First, because they are doing some write to the storage, even if it's not a lot, and also because they are in the network. But now on the storage, I would like to see something equal on all nodes because I want to distribute it. And here I see that on 2 nodes, I have some CPU usage. And on 1 node, I have one more thing that is waiting for replication. And waiting for replication, this is the Raft consensus. We write and it is replicated to the other servers. So apparently, my writes all go there and then they are replicated to the others. And they all go there because the tablet is there. In Active Session History, we have also the tablet ID, and we can link that with a view that has the information about tablet. So first, we have also the statement ID that we can link to pgstat statement. So here it is easy. I have only one query. So of course, on the query layer, it's the insert. And the good thing is that we also push the information to the storage layer. So in the storage layer, it knows which query it was. But more interesting is the tablets. So here I have the tablets per servers. And so you see that on the other servers, I have sequences, yeah, because I'm reading from a sequence and I have the default cache that is 100. I have transactions because we have a transaction tablet to be able to set the commit status, but more activity on this server on my table demo tablet. Just because I didn't distribute it, I use range sharding. This starts with only one tablet. When there is more data, it is automatically split, but I don't have enough data there to get it split. So one way for small tables, one way to distribute more the inserts is using hash sharding. And let me just check. Yeah.
And to answer the previous question, we do have tech preview features for fall forward and fall back in Voyager migrations.
Cool.
So that is something that people can look into if they need to fall back to the source database that is available for testing now.
So when I was saying that we have a lot of new features in each release, you see, as developer advocate, we discover new features from questions. Because there is a lot ongoing, yeah.
Tons.
And so let me recreate my table with hash sharding, where we just use hash keyword there. And this has the advantage that it already create multiple tablets, because with range sharding, you need to know the values to distribute it. With hash sharding, it applies a hash function of it where we know the value. So it's quite easy to distribute immediately. And by default, it creates one tablet on each server. So what I expect to see there is better distribution of the writes and maybe higher throughput if there is no other bottleneck. Looks like we don't really gain in throughput. But also, I can mention that my lab, I have 3 nodes, but on very small nodes. So yeah, probably there are other bottlenecks. Let's see a question or a comment from Yao. Please consider having community QA if possible. So many questions. DR related, migration related, monitoring, self-hosting. Yeah, thanks. Those are good topics for the next open hours. We will keep that in mind. And Voyager in the doc, yeah, support only old versions of Postgres. Okay, taking a note also about that, Voyager should be able to read even newer version of Postgres. I think we have something in the doc that is not correct there because I used Voyager from... The thing is that currently YugabyteDB is Postgres 11 compatible. But you can use Voyager from newer version of Postgres, and it will tell you if you use a feature that is not yet there in YugabyteDB. We will be Postgres 15 compatible soon. I think it's for end of the year in preview. And
exactly. I think what they're doing there is trying to match the official compatibility with Yugabyte potentially in the documentation, where, you know, with this migration initiative that we're working on, I've migrated apps on Postgres 16 using Voyager. So that's just something to note.
And the good thing with Voyager, it tells you, it tries to detect the features that we don't have so that you do not waste time. You can see, okay, this application, I cannot migrate it to Yugabyte today. Let's wait. I mean, you don't want to do a whole migration to discover later what is not supported.
And it links to GitHub issues for things that are actively being worked on, which is really cool.
Oh, good. Yeah. And if you have something that is not supported, please comment on the GitHub issues because the priority, all those are in the roadmap, but there are priorities, and the priority comes, of course, customers with support have higher priority, but community users, open source users, will get higher priority if they show the value of it. For example, if you say there is this application in Postgres that is used a lot and we need this feature, that probably it will be higher priority. So here, what I have now, so similar on the query layer and my Raft replication are better distributed on all nodes. So it doesn't really change the throughput there, but at least I'm a bit more distributed. I have no idea why this node where I'm not connected to add a catalog read, but also with sampling, be careful if it's only one single sample. Of course, it reads the catalog to refresh the caches. The statements, I know them. And about the tablet, so I can see that in all nodes, I have this demo tablet, and those are the ranges of the hash keys. So because now I have 3 tablets on each node, I distributed the workload. Let me look at the time, and maybe I can show something else. I've also put the tablets in another way here to really see which tablets are active. So that's something I expect. I'm inserting in a table that is distributed on 3 nodes to 3 tablets. So I see that the 3 tablets are active. So that's good. And I see another one that is not active a lot, but still, maybe we can improve something. The sequence. Because I read from a sequence now with big serial, and it has a default cache of 100 in Yugabyte. In Postgres, it's 1, but in Yugabyte, it's 100 because you need that to scale. And maybe it's not sufficient, this cache, it's not sufficient for this throughput because I insert 2000 rows per second. So with a 100 cache means that we are still reading a lot from the sequence, and the sequence is a single row in the sequence table. So we need to distribute that. And the last thing I will show maybe will just be altering the sequence with a higher cache, and we will see what it changes there. And while it is running, let's see at the questions and remarks that we have. So we have one question about the documentation of the not supported features. And yes, we have that.
Yeah,
If
so
we go to doc,
I
or
provided
you
a
have it,
link.
maybe you
I
can.
provided a link
Okay,
to
perfect.
the feature support, and then you can check out Postgres compatibility as well. So we
Yep.
should have a number of GitHub issues linked within the documentation as well for things that are, the support is always being added to. So
And also, if something is missing in the documentation, please open an issue or give some feedback, because it's not always easy to catch up with the documentation with so many features coming. So
they do a
I don't
very good
guarantee that
job.
the documentation is 100% up to date.
Mm-hmm.
Okay, so what do I have here if I refresh and show the last 5 minutes? Or maybe I will show more. So that was my run before. That was the new run. Okay, it's quite similar. On the tablets, I don't see my sequence anymore, but probably it has not changed a lot. So even if it doesn't change my response time and my throughput, at least I know that I'm more scalable with a large cache, which makes sense for this ingesting a lot of rows.
I guess you could use a UUID data type. How would that impact things?
Yeah, UUID, you don't need to read the sequence, but
Yep,
I don't really mind about reading the sequence if it's not too often.
exactly. With increasing the cache size, you're mitigating
Yeah,
a lot of that issue.
but UUID is also a good idea. It's usually not a random UUID is usually not recommended in Postgres because Postgres uses B trees, and it's good to distribute the value. The problem with a sequence is that it's always increasing, so it always go to one place. If it's a random UID, it can really go randomly everywhere. And the best is in the middle. The best is not going to one place, but also not to all blocks, because then you have a lot of cache miss and random reads and whatever. So in Postgres, random UIDs are not really recommended from a performance point of view. In Yugabyte, we don't really care because we have LSM trees, and it works really differently. It doesn't try to place immediately the row like within a B tree. It goes to the memory table of the LSM tree, and then compaction will place it in the background. So you can use UID, you can use sequence. For the indexes, it doesn't change. The difference is that sequences have to read a single point of truth, not always because there is a cache, but also there are some consideration with the cache. The cache is by default per session. We have also implemented a cache per tablet server. So yeah, there are many things that can be tuned around it. And also, a lot of Postgres applications are using sequence, so to be Postgres compatible with the application, so that they don't have to change their code. We support sequences and we improve it. The bug that we have seen with those catalog reads is something that was fixed quickly and will go on the next version. Okay, one more question. Do you guys provide service if we went to self-host, like consulting, review of the cluster setup and so on? So basically, YugabyteDB is open source, and the support we do is community support. So you will see Brett or I or other colleagues in the forum, in the community Slack. And yes, if you have questions about something that you self-host, we can help there. It's best effort when there is no support. Of course, you can also get support when it is self-hosted. And then also you can ask the question where you went, and then the pre-sales will see with you what they can do with consulting or support. If you run production, it's probably a good idea to have support for any database. But I know that there are some users using Yugabyte open source for production without support. If the workload is not critical, that can be okay also. But yeah. And yeah, paid support, yeah, sure. For paid support, just ask, and we will get the pre-sales people. They know better what we offer in terms of support, especially if it's short-term support to review a cluster. So yeah, just contact us in any way, and the pre-sales, depending on the regions, will help you to get support and check your cluster. Yeah.
Yeah, I would recommend everyone join the community Slack. People are very keen on answering questions there, and we get some interesting discussions almost on a daily basis in there. So
Yeah.
join us over there.
And then yeah, and then just ask for sure, if on the community Slack you ask for paid support, you will get the right person to answer your question. Of course, it depends on many parameters that us developer advocates. We don't really know. Okay. So we are just on time. Let's see if there are more questions. I didn't check. Sometimes the LinkedIn is not always synchronized. Let me check. I'm looking at LinkedIn on my phone for that, because when I had it open, I had some bandwidth problem with the Wi-Fi. So apparently, we don't have more
No, I don't think so.
questions on LinkedIn. And anyway, this goes to YouTube, so you can watch it later. And all feedbacks, questions, feedback, anything are good. What we see there, active session history is really new. It will need to be used to be improved. Maybe we need more wait events or more information. For example, Pete asked to get the I think it was the session ID in active session history, because it was not there, and that's a good idea. Let me check. I don't know if I have it in this version. YB active session history /D. Do we have the YSQL session ID? So I don't think it's in this session. It's in the next. It's not the same session ID. I'm not completely sure. But basically, you see that we can also add more information. It's always a trade-off. The size of this information is easy to control. It's the sampling frequency and the number of information. And if you add more information for each sample, it means that in memory, you can store less buffers. The idea is that the overhead is minimal. And that's also what is good with sampling. When you add counters, the counters add some CPU, some system calls sometimes to get timing info. With sampling, it's just looking at what the sessions are doing. So it's I think it should be, for the moment, it's in preview, but the goal is that it's always there and always running. And it's the first thing to look when you think that something is slow, just to drill down to what you need to tune.
Very cool.
Okay, so that was great. It was really nice to have Kyle there. Of course, knowing a lot about performance insight on Postgres and all this sampling activity. It's really something that Oracle did, I don't know, 20 years ago, maybe, or 15 years ago. And it's really a good idea. It's something that exists elsewhere. For example, when you run top on Linux, this is the idea. It samples what the tasks on Linux are doing, and yeah, good to have it in the database. Okay, thank you very much. Thank you, everybody. Thank you, Brett. And I think the next open hours will not be in 2 weeks, but in 3 weeks. One reason is that I will be in New York for the Postgres conferences, and we will have a guest, but you will see more on social media there.
Yeah, and stay tuned for the announcement tomorrow.
Oh, yes, yes. Okay, goodbye.
Have a good one. Bye.